Okay, so let's talk about solar spectrum here for a sec. And let's get me a nice pen. That is a nice color. I don't know why that blue box is there. Maybe it'll go away in a minute. Okay, so spectral lines. So what is a spectrum? Spectrum is, I guess it's a way of seeing all of the individual wavelengths of light emanating, how have I spelt that right? Emanating from a source. All right. So what if I do this? So who here has ever seen a prism in action? Have you ever seen a prism? Okay, so a prism, and I have one, and I'll show it to you in a second. But a prism is basically just a brick of glass that's shaped like a triangle. And what happens is if you shine some light into the prism, that light happens to be white, the light does something called refracting when it strikes the surface. Basically, more or less, what that means is its speed changes, and it changes direction a little bit. And it's going to do this again when it strikes the other interface of the prism, okay? But interestingly, okay, if this source is what we call white light, so this is like the light you'd get from the sun, or from an incandescent lamp, okay? If white light strikes this thing, the different wavelengths that are contained in white light spread or bend to different degrees, okay? So it turns out that purple light bends the most. It bends more than the other colors. And you end up with a line of purple there. And at the other end, red light, it bends the least, okay? And in between, you get all your different colors of light spreading out. So what are the colors in the rainbow? Red, orange, yellow. What else is there? Green. I just stuff blue in there even though it barely fits. Okay. And so the spectroscopes that we just looked at basically fulfill the same role. They use a little bit of a different way of doing this, but they fulfill the role that that a prism would do, okay? And they take in white light, which is a mixture of all colors of light, and they spread it out so that your eye can actually see what is in there. So there's your eye. Okay? Now, if all of these strike your eye at once, you're just going to see white. Okay? So the mixture of all those colors you perceive with your eyes being white. Okay? So the spectroscope that you have there allows you to spread out the light into different wavelengths. Okay? That all have their own different colors. And it turns out, by the way, that purple has the highest energy wavelength, and it is the shortest wavelength. Okay? And if you go one step further beyond the visible spectrum, you get into the UV light. And if you go into longer wavelengths, you know, down over here, okay, you get into infrared. So all of those things are related to light itself. So if we just quickly draw your tube, okay, so there it is. What it has on one end is a cap, like a slit in it, okay, and that's where light enters. And it's white light. If you're looking out the window, it's white light. That's what comes from the sun. Sunlight contains all the colors of light. It comes through here, and in the other end, you have this little window. It's got a grating on it that does the same thing as a prism. And if you kind of look off to the sides of the grating, like over here and over here, that's where you see, where you perceive your rainbow colors, like kind of over here. I think everybody saw that. So that's more or less what's going on. It's refracting the light. This is called refracting the bending of the rays. If you're interested in that, if you take physics next year, we talk about that quite a bit. So that's what happens. Now, you need this background because we're now going to look at stuff that is not white light. So the first thing that we're going to look at is the fluorescent lights in this room, okay? And I'll explain how the fluorescent lights work a little bit later. But the first thing you have to do is take a look at them and see what you see in terms of a spectrum. So I'm just going to stop it there for a second. Sunlight, right?